All right, you guys, let's continue. Political Action Group wishes to learn the government approval ratings on the environment. From a past study, they know they will have to poll 270 people for their desired level of confidence. If they want to keep the same level of confidence but want to divide the margin of error in third, how many people will they have to poll? Okay, do you remember that one, you guys? Remember the square root of all that? So how am I going to get 1/3 when it's the square root of that, you guys? And so what you're going to have to do is square that third part, and it's going to be 9. So I get E on this. So divide the interval estimated by, and I just chose the word D, or the letter D, sorry, without affecting the confidence level. You multiply the sample size by a multiple of D squared, because remember it was that square root when we did that formula. So the square root of 1/3 is 1/9. So in this case, it's going to be 9 times the 270, which is choice E. Okay. All right, so using the same data, not from the before, this is just a whole new one. One student performs a test of H naught or H sub 0. H sub O is the proportion is 0.85, and your alternative hypotheses, H sub A, that's what this is, alternative hypotheses, is it doesn't equal. So this is a two-tailed dude right here, okay? So proportion doesn't equal 0.85. A second student performs a test, H naught is 85% or 0.85. With the alternative hypotheses, it's less than 0.85, okay? So even though both use the significance level of 0.05, the first student claims there's not enough evidence to reject H naught, and the second student says there is enough evidence to reject H naught. So which of the following could have been the values for the testing, the statistics? Okay, so we got to go and find our scores for the 0.05, you guys. So a two-sided test with a significance of 0.05 has a critical z-score of the 1.96 plus or minus, while the one-sided test has a critical z-value of negative 1.645. Okay, so the only answer that is further out from negative 1.645 and not as far as negative 1.96 is the only one is negative 1.8, so it's choice B on that one. Okay, so you got to find your z-scores for their two-sided at 5%. So, and remember, you're given all these tables. You just got to know how to use the tables, you guys. And then you got to get your one-sided significance at 5%, and then find your z-values, and then find out which one where that number falls in between. Okay. All right, hope that makes sense. I got stumbling on my words there. All right, now one-sided hypothesis test for the mean, a random sample of size 15. The t-score of the sample mean is 2.615. Is this significant at the 5% level? Is it at the 1% level? All right, so what you got to do is with 15, your degrees of freedom is 14, and your critical t-score for the 5% and the 1% probabilities at 14 on your t-score is 1.761 and 2.624 respectively. So they gave us the 2.615, and since it's greater than 1.761, but it's less than the other one right there, so it is significant at the 5% level, but it's not significant at the 1% level, okay? Because it's farther extreme than the 5%, but it's not farther extreme than the 1% t-score on that. All right, a guidance counselor wishes to determine the mean number of changes in academic majors by college students to within 0.1 at the 90% confidence level, okay, plus or minus. So what is the sample size should be chosen if it is known that the standard deviation is 0.45. Okay, remember our margin of error, our sample size calculations is your z-score, your standard deviation divided by the square root of n, is less than or equal to the margin of error. So the 90% confidence, your z-score is 1.645. So plugging them all in, I get my sample size has to be greater than 54.8, so I'm going to use 55, choice C. All right. Okay, the principal, Mr. Wolf, is informed that among the 1,850 students at his high school, the average GPA is 2.13 with a standard deviation of 0.61. Okay, so that's the GPA of the whole population. Okay, so what is the margin with what margin of error is the mean GPA of these students known? Okay, all right. So since the 2.13 is the average GPA of the entire population, then there is no margin of error. So that's the entire population. So the margin of error would be 0, choice A. Okay, all right. Because it's the entire population, it wasn't a sample. Suppose X and Y are independent random variables, both normal distributions. If X has a mean of 30 with standard deviation of 6 and Y has a mean of 25 with standard deviation of 4, what's the probability that a randomly generated value of X is greater than a random generated value of Y? So I need to find the difference of X minus Y, and so I want to see if it's greater than, then it would be greater than 0. So X minus Y, the distribution is going to have a mean of 30 minus 25, or 5. Okay, and the standard deviation, remember, is going to be the square root of the sum of the squares of their standard deviations. So the standard deviations of their differences is 7.211. And so from our formula before, remember, z equals x minus the mu divided by the standard deviation. Well, we want to know it's greater than 0, so 0 minus the mean that we have, 5, divided by the standard deviation. So I get a negative 0.6934, but we want greater than. Okay, your book always gives you to the left right here. Okay, so it's going to be 1 minus that, so I get 0.7560. Okay, and then to do that in your calculator, you do your normal CDF, and so you're going to plug in 0 because that's we want to know it's greater than 0, and we want to go to the right, as far to the right, so we choose a large number. We always do 1,000. Okay, there's our mean, there's our standard deviation, hit enter, and we get the same score right there. All right. So which of the following are true statements about the chi-square distribution? So for small degrees of freedom, the distribution is skewed to the right. However, for large degrees of freedom, it becomes more symmetrical and bell-shaped. That's true. Okay, so number 2, for 1 or 2 degrees of freedom, the histogram peak occurs at 0. For 3 or more degrees of freedom, the peak is at degrees of freedom minus 2. That's true. I really didn't discuss that in our class too much, but that's a true statement right there. It's always minus 2. So there's a separate chi-squared curve for each degrees of freedom. Well, that's true also, just like the t distribution right there. So all 3 of them are true. So I get choice D on that one. So like the t distribution, there's a separate chi-squared curve for each degrees of freedom value. And like the t distribution, the larger the df, the chi-squared distribution gets more bell-shaped curve. All right, so when there are multiple gaps in clusters, which of the following is the best choice to give an overall picture of the distribution? Okay, well, mean and standard deviation. Can you see your gaps or clusters? No. Median and interquartile range. Can you see your gaps or clusters? Yeah, maybe. Not too well. Box plots with its 5-number summary system. Well, that might as well be well, that's your box plot right there, and that's not. Stem plots or histograms will show you your gaps, you guys, and it's asking for gaps in clusters, so it's going to be choice D. Those are stem plots and histograms can show gaps in clusters that are hidden when one simply looks at the calculations, such as mean, median, standard deviation, and quartiles and the extremes. You can't see those gaps and stuff. So which of the following statements about correlation are true? Okay, when r equals 0, there's no relationship between the variables. And we're probably thinking, yeah, that's true. It's not. It's not. When r equals 0.2, then 20% of the variables are closely related. Well, that doesn't make sense. So when r equals 1, there's a perfect cause and effect relationship between the variables. Well, that sounds pretty good too, but this one's a trick. These are all misconceptions about the correlations. Correlation measures only linearity, whether it's a linear relationship or not. So even though when r equals 0, there still can be a non-kind of linear relationship happening. So so that doesn't make 1 true. And correlation shows association, not cause and effect. So none of them are true. All of them can be false, okay? All right, got a couple more here. So a consumer product agency tests kilowatts per hour for a sample of refrigerators, each of 3 different sizes. Which of the following is true? There are 3 explanatory variables and 1 response variable. No, they're just testing 3 different refrigerators, you guys. There's 1 explanatory variable with 3 levels of response. No, there's not 3 levels of response. We're just measuring kilowatts. Kilowatts per hour is the only explanatory variable, but there are 3 response variables. All right, so let's just jump to it. So there's choice D because the size is the only explanatory variable, the size of the refrigerator, and it's being tested at 3 levels. So kilowatts per hour is the single response variable, so it's choice D. All right, so there's 8,253 men and 10,327 women at the state university. If 43% of the men and 27% of the women are business majors, what is the expected number of business majors in a random sample of 200 students? Okay, so what we got to do is find the probability that the student is male. So we add these two numbers up, that's the total, and so I take the male divided by the total, and it gets me that. And you can do the same for the female, or you can just do 1 minus that, because it's the only male or female in there, so it's the complement of that. So that's the probability for male and female right there. So we're just going to take the 200 times the probability, whether it's male, and then times the probability that that it's a business major. Okay, and then same for the female, and we get 68.2, so choice D. All right, take care, you guys.